take home assignment. Okay, so they give you a route. Okay, it's used to convert carbonyl compound into alkenes. So these are carbon, right? P oh no, it's phenol. Sorry, phenol. Okay, so there's 3 benzene group here attached to a carbon. So this conversion, right, is P, phosphorus lah. Peacock, right? It's a peacock. So they label this as carbon B and this is carbon A lah. Okay, then they have a R group 3. So this actually to help you to differentiate where the movement goes. This is 1, 2, 3, 4, 4 different alkyl groups, carbon A and carbon B. Okay, so what happened is, oh, this pen, so nightmare. This is carbon A, then you have carbon, and you have carbon. Right? So what you do is when you remove this double bond, then each of them can have one bond, right? But you will form this one and this. Okay? Then you get your intermediate. Okay? Then to get your alkene, right? What happens is it breaks off here alkene, here P double bond O. Okay? So anyway, they ask you the type of reaction for step 1. You wrote nucleophilic addition. Nucleophilic addition. This is a nucleophile. Then it's here. Okay, it's possible. Then state the hybridization for carbon A intermediate S3. Okay, correct. Then the bond angle of asking for right is 90. Or asking just why it happens very rarely, because strain. Strain, you see this is an SP, right, as mentioned in B part 1, right? So because it's supposed to be SP3, the bond angle is supposed to be what? 109.5. Yeah, but then it's been forced into 1 degrees, right? So of that is unstable due to strain. So due to that is unstable, then it will be able to form more stable product. Really? Right. Okay. Unlike the carbonyl reactant, alkene does not react with the negatively charged carbon B on the light. What is this one? No, you like this one. Because this is negative, this is electron rich, so they repair. Yeah, I still have electron negative. So okay, so unlike the carbonyl reactant, an alkene does not react with negatively charged carbon on the elide. The alkene does not react with the negatively charged carbon at the high electron density in the electron rich. CC double one tells a negatively charged CB. Right? Yeah. FYI, this question, this reaction, right? Often they will give you the the so they'll give you this first line, right? Then they'll give you like a reaction. Then they ask you what are the possible products from the reaction. You have to get the correct one. Okay, so obviously it's a reaction you never learned before. You need to decipher the move on how they blend from the bonds. Okay. Okay, then they give you further details on the mechanism. Mechanism for step 1 and 2 which is shown in figure 1 is this. Okay, so arrow, this bond is broken and then yeah. So the CaO pi bond is broken. So he did a heterolytic fission here lah. Okay. So if there's heterolytic fission here means if this comes has to be a fission. Yeah. The A, C, and P bonds are never do the arrow. Mountain to give the intermediate. This is determining. There are bonds bond. When you do this, yes, you form CA bond, but you never do the P. That one, right? Okay. So take note. This you must have two bonds being formed. So you should have arrows. This is broken. This step 1 should have arrows. And CaO and CP broken. Okay, so step 2. So this one broken, this is broken, and then you have formed simultaneously. If you breaking and forming bonds simultaneously, right, your arrow will be the so it's more like one. Okay, like right here from right here from before. This one lah. So this is breaking to form the one. I cannot draw that one. Then this one is broken. Then this one. So this one. Then you form this one. Okay. That's still okay. Not very difficult. Okay. Then this one your subject structure. So MC usually they give you, then you choose the correct one. When you draw your skeleton, your one right should be on this side of the thing, not like that. Yeah. Because this way. So you should draw one pointing.
My structure is
Also, let me see. They form with them. If be a side. Let me see. If I have this and this. So long story is cut here. Cut here. So you cut off. Wait, one low there,
cement. I'm showing the cement.
Oh, okay. Oh, okay, got it. Then this is head. So you off this one. Then here join. So basically here go to this one like that. So wrap the ring.
The old one.
The old this one. And this form.
Yeah.
This is reaction. Ignoring the balance, right? Summers is here you this one.
Yeah.
Then here to here, you this one. Right? This is a long story. So story, oh. Here, here, then here, double barrel. Then you arrange to a ring, you count, then you like a hexagon or a pentagon accordingly. Just look at our horror photo. Wow, you're planning. Eh? How come you give me?
Yeah, correct. Primary.
Oh, okay, okay. Looks like I need to do more plan. Yeah, is that okay? So easy. Oh, yeah, that's my meal. Hey, what do you eat?
So sad.
You went okay. Yes.
I think you just forgot what titration was.
Dietary planning here.
You know, people they just wrote conduct titration and get like just one line, get a mark.
Okay, 60% hydroxide, solubility in water. Mm. Yeah, some calculations. Okay, at least the plan will give you some. It's not bigger base. Calcium is more soluble. Oh, okay, get this.
Yeah, I got about okay, you know, and study it. Like these and I don't
Very neat.
I don't know.
Please. So, your square like so perfect.
That's the thing. In the end, because
That's
everybody
your give it and oh yeah. Usually you should and come and solve it as much as you can.
look at my I don't know my now. I was just last time.
Look at this. It's not like you all need to know the effect of your arrows. You know, need to know the effect of your arrows. Like just now, right? Like for this one, if you to break a bond from a bond, right? Your arrow will be bond. Okay. Then time, the other time, like here, right? And uh, when, one of them have to let's just say one of them acquire a chart. You see in this case, he didn't. He left one right, left out the he left out the blah, 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 the OP. If you didn't do OP, then here will acquire a negative charge. So should be here, here lah. So if you did right, if you do right, then your here will a negative charge. Okay. So similarly, in homolytic fission, how every bond, right will have electron. Each hydrogen, right, movement of one electron. You do this, right? This is that if you don't have a matching half a bond match, this would have a that's why you bring in to then form half basically, right? And this half that's become a radical. Okay, so you need to be a bit more intuitive in the movement of arrows. Okay, whether it will remove a charge, new bond, okay, or form particle. Okay, then
And just
Bound G is a cycloalkane and an isomer of ethyl cycloalkane. What's is mentioned?
Yeah.
To draw.
It's just
Oh, the okay, the cycloalkane. Okay. Then H and I are typically active. So we are let's try. Give you paper. My paper is okay. Our is an item of so take like the okay side is where and means in so how is that one is like number two you must have okay number 2 1 2 4 5 6 6 cannot. Then I get no column. 2, 5. The double bond. Cycle. Mm.
From 2 more bonds.
Hmm?
I can't different from 2 more bonds.
Hydrogen.
Can't.
Yeah, I can't. Because there's criteria for alkene.
Oh, I see. Oh,
Yeah.
man. I have I just
We try 1, 2, 3, 4, 5, 6.
but that be carbon.
No, the G and the G, the other one, the G2. Oh, wait. Yeah, 2 correct.
One and 2 from the
True. Oh, trying.
yeah. Give the answer.
Hmm. It's a lady. Oh, so how you do only 2 stereomers, I guess.
What?
The
But if this is 2, isn't this symmetric?
yeah, so like the it's the there's always plus minus. So like the minus will be equal to plus. Like you draw the other isomer for each of them, right? Is equal to the other one from the other side. Because all the same. So they will have a optical isomers that coincide with each other. When you draw, right, there's a plus isomer and a minus isomer, right? The minus isomer will be equal to, because it's because when you rotate it, they will superimpose and then they end up being the same molecule. Then they become not isomer. In the end, you have 2 only.
But
Because they like
they are because like isn't it symmetrical?
No.
This is a carbon, right? Then there's this, then there's the H, right? Then like for this, isn't it symmetrical?
actually in a way.
It's
yeah.
symmetrical, right? I'm mad.
It's not a very good question to be honest. But then the type of isomerism, I say it's not stereo. It's not in. Oh, okay. It's not optical isomerism. It's the trans, right? I tell you have like you can all of them above plane or all below. So imagine you have a triangle, right? Okay, then they each have their so-called branching, right? So they can be like above. Okay, imagine once here. Can all be can be like one be like that. If they're all on the side of the plane, right, then you have a cis isomer. If you have one up, one is a trans isomer. It's not the single isomerism here is not enantiomerism, not optical. It's not enantio or optical amerism. It's cis trans isomerism. Metric. Not necessary. Not necessary. The other case is when you have cycle. Then yeah, so either they are all above on the same plane, or they have one above and then one below, and then another one below. So this is trans. But it's a bit unnecessarily painful. Bring your thing. Look at us. Next part. I'm not gonna show you things.
Scared.
These are people who cheat.
Cheap meh?
This is what usually
Oh,
like, you know, for the more like cool
I
class.
think cheat also don't use so hard.
Yeah.
Like the blind, the
Really sharing on.
quite cool for you. This like it was a thing that should have the phosphorus side change plane and have born and got 120, but they've been to be 60. Right? Okay. Subsequently, the particles met with water vapor. Particles they see in a small granite circuit, this white phosphorus stored in a canister is allowed to burn when sparked off used to put particles. Subsequently, the small area of a fume being even more effective. How do you get phosphorus hydroxide? I've never seen this before. It should be when it is more effective, right? Your result is you should be like right the drop must have more moles or something lah. You, maybe you should have done like P4O10, then it breaks down to P2O3. Like, you know what I mean? When you burn oxygen, P4O10, then it will break down to P2O3. Phosphorus containing got ionic behavior. Not bad. Oh, no. I wonder whether you can calculate. Oh yeah. P4N. Not break down to 2P2. It's break down to 4 more 3PO4. Okay. So now they ask you to predict. Okay, ask you to predict basically Why need to predict? Not basic. Using the figure 3.2. They're asking for what? For 3, huh? It's for 3, right? Then only these two. So die basic. Oh, you got it. But why didn't you get a mark?
Also, is that
Go and write about 4, 5. Answer very fun. You say that this is basic because the 5 is 3 OH, so dissociate 3 times. But you didn't have to talk about the other one. They didn't ask you about the other
I
one.
don't know why I said that.
Yeah. So it has 2 OH group. So it will dissociate twice. It has 2 OH group that allows. Actually, I should explain this question. What did it? There are 2 OH group that are highly polarized. Oh yeah, because it's OH, so it's highly polarized. So because H bonded to O will be able to dissociate H protons because the OH bonds. Okay, because the OH bonds are polarized. Okay, then protons are easily lost. 1 mark. That you all look at that. This is a 1 mark. Aren't they asking a bit too much?
Yes.
This is 3 mark answers, yeah. Okay, so only the hydrogen bond to the highly electronegative oxygen atoms can be dissociated and can be lost as a negative charge on O minus be derealized by resonance. As the hydrogen bonded to these phosphorus cannot be lost because the negative charge on the P minus cannot be delocalized. So this OSC can be localized. But then this H, right, cannot be lost because firstly it's not as polar, and secondly the what do you call it, the you have a negative charge cannot be utilized because there's no what do you call this neighboring p orbital. This one has, you see here, right, p orbital here there's a p orbital, so the charge here decomposes from this p orbital to the edge. Remember the metal ordinance, right? If you have an alkene, like a group here, for example, here orbital, here pi orbital, right? So by resonance, like bond is strengthened during adjacent pi bond. So you will see the popular MCQ question ask to guess the average bond length of this, and the average bond length of this is between that of a CH or rather a CC bond and the bond is between these. It's like shorter than this, longer than this due to the elements.
Why are they talking about H atoms like protons if like it's about basicity?
Basicity determines how many protons.
I thought it was how many.
Basicity doesn't mean it's basic. It means it's brief.
Oh wait, sorry. Something else. No, looking at H groups.
Okay, then they ask you to calculate Y. So they ask you to calculate Ka1. Do you manage to calculate?
I messed up at the last part.
Okay, come here, I'll try and calculate. Okay. Yeah, carpet. Right. One. Is that a question on this thing? Okay, not sure. Just go from the. This pen is like dying. It's like bleeding to death. My pen is bleeding to death. My friend last time. Why do you use this? Don't use it dry. Peace. Hey, take paper and try ah.
Reading.
So, it says 0% mass. Give you pH over. Do you calculate the acid concentration over here?
Yes.
Okay, cool. So remember, concentration of H plus is equals to square root A times C, right? This is the formula you need. Your A, right, will be equals to concentration of H plus square over the concentration of the H3PO4, right? So now you just need the individual elements compute for this. So the concentration H plus is 10 to the power of minus 2.46, right?
Yeah.
Square. Then now we need to find the concentration of H3PO4, which is this equation they gave you, right? That you have to use. They gave you, so you can find concentration of H3PO4, right? Then you have to minus away of the because so use this to be able to find the concentration of H3PO4. Yeah, guess how to find. Okay, you know, I want the concentration of H3PO4. How do I? You don't need the to this one. Need
C just sub in
how to sub?
KA.
No. You ask 1 KA. Why?
And of three, four.
0.25 grams.
0.05%.
Okay, so
Over the amount of fuel divided by 500 cubed.
then you need to convert to.
DMQ.
Okay. So you take minus the divided. So minus of 1.6. Then a bit unconscious. Okay. Oh, pH of water. The only thing you can do is write the equation. Why you write like right in the middle? Calculate about Naomi. It's given, huh? It's given the.
Didn't see it.
You can try calculate the buffer. You want some equilibrium like this. Take note of dilution. Okay, so the formula pH equals to pKa plus log concentration of salt. But actually very simple. This one is a giveaway. Okay, so minus log. Okay, the value is given to you. Take note, sometimes they give you the pKa value instead of the Ka value, so careful. Don't go and log it. In this case, they give you Ka. Okay, this is sometimes you don't calculate the because they'll be the same. So we use a lot when we were doing the concentration curve, right? So plus log concentration of salt. So which is the salt? Is it 1? Is it 2?
Two.
2 is the salt. This one is the one that will. This one is this one. So it's the one that will remove the acid. Yeah, correct. Okay. So number of moles of the salt 0.2 times 100, right? Okay, don't because the bottom also divide by 1000. Okay, then 0.3 times 5. Okay, then you strike out the zeros, do your math, your pH. Your answer is 5.3. Okay, it's easy to use calculator. Can?
How you know Na2H4 is the salt?
You see, this is the two components, right?
Mm.
This one will dissociate into this, correct or not? This one dissociate the acid, that the acid not. Then this is the conjugate base, right? So the conjugate base is the one that will remove the acid, which means it acts as a salt, because this is the acid, correct or not? If one is acid, the other one is salt. Okay? No, could do this. The removal. Why wrong? You use the to remove this. See, right? Ouch. Hey, you also.
I put double arrow by accident. What's this single arrow?
Okay, whenever you show using acid, double arrow, it's a very bad mark to use, my dear.
Suddenly everything seems like so easy.
Yeah,
now.
it's not
Then,
like
talking about this. Remember the
No,
alkanes
as in,
question?
Not that, but
that
like,
one. But yeah, this is
then I don't know. We didn't do.
later. I'll talk about the marks that you should have gotten. Okay, from the beginning. Let's not talk about the planning. Okay. Yeah, I don't want to talk about planning. Okay, this one okay lah. This the page. This whole page you're supposed to get the mark. Okay. Then this page. You look at the question. Stability of done this in your this or not? Cannot. The stability of their radical. We went through this before. What? So this whole page you should have gotten the answer. The marks. Okay, this one how many marks? 5 marks. Okay, we get 5 marks. Still, this one 5 marks. There. Turn. This is period 3. Cannot. This one should at least have gotten half the mark here. Okay. This one should have gotten. This one should have gotten. And that should have gotten. Okay, now 7. That's a trend description. This looks like A-level question. I've seen this before. So describe and explain how sorry here. Describe how thermal stability of diatomic interhalogen compounds formed by iodine series down. Thermal stability. So you talk about how the more the bond, right or not? The thermal stability. Thermal stability means how easy it is to break the bond, right? Right, the IF bond, the ICR bond, and the IBR bond. So you can go by the bond length. I don't know if they got bond. I suppose not. Right, but being the bigger one, right? So this one has the longest bond length, right? So this is the easiest to break, hence the least thermally stable. Then converse will be true for IF. This is smaller, so smallest, shortest bond length, so most thermally stable. Okay, I don't know. It's not. It's a covalent compound. I am. Your teacher didn't write. It's a covalent compound. Okay. So please bring up ion. No charge, so you shouldn't be talking about charge density. Okay, and I think that's where you lost your mark. Actually, you were not bad. You got 2 marks. I got giving you 0 to your. Okay, then the is to the benzene. A Lewis is at least is required. It's already polar, right? So there's already a electron present for it to undergo electrophilic substitution. You're right. So, no. Electron can be generated without catalyst. Actually, quite close. What's your teacher right? What's his word?
Which is
Wait, can attack the electron-rich benzene? Then mechanism. 2 marks. Oh, because you never write the mechanism. Okay, last time I'm gonna mention this, right? Before you start mechanism, please at least write the name of the mechanism. Okay? Can? Aye. So funny, but got so much. Did you realize that?
yeah.
You have this one bromide sensitive to light or low frequency than chloride ions. What is this? Okay, so the halide loses electron, becomes the unstable atom. Because bromide have ions have a ionic actually on track. No time. You're on track with fabric.
Then not.
Hence it's easy to lose the most electron. The distance in the nucleus, the outermost electron is further, right? And more is further, so it's and there's one more electron shell, right? So there's more shielding also, right? Hence it doesn't hold that last electron as tightly. So it's easy to lose. Compatibility, chlorine and iron. How come you didn't do this one? Just compare MR only. Chem bonding question. Chlorine and iron because chlorine has a smaller MR, the smaller electron cloud. Hence the ID is weaker, right? Does this sound easily familiar? Right? This one also has lost. Not like you study also. Yeah. The in reaction between thiosulfate and then halogen show that chlorine is a stronger oxidizing agent than iodine. With the aid of equation and considering products formed. Okay, this one is not hard, but it's just whether you got memorized or not. That's the two thing in the 3 years memorize in the group in the book. Okay, it's really whether you got memorized or not. This one. How to that one, right? Even if you never remember now, never mind. Before go and find all stars and make sure you memorize the stars. I ask you all stars. Okay. Synthesizing, draw displayed formula. Yeah. formula. What's wrong? Yes. How many times I tell you this spec formula must show every single bond. Let me check whether your structure correct. If you lost mark because of this, that is very sad. No. They ask you to draw what? Display or compound A, this one.
Oh, I
4
forgot
bromo.
the reaction. I didn't know Al2O3 was formed.
Remove elimination of
Yeah.
water. That's why I tell you all right, you all cannot just memorize that one. You all know also. You use one for cooking. You need to be familiar with the other one that you're memorizing for. Okay? Al2 catalyst. Okay? Then when you heat, right, it will remove water. So the OH will be removed. Why you got double O one? Double wrong already. No. Bro beaten one. You're supposed to turn on. Then you got bro. Okay, it's not a ketone. Sort of. Yeah, you turn into a ketone. I don't know what is this. Okay, this one is you're supposed to drop butanol. 1, 2, 3, 4, 2, 3. Okay, this is one or okay then
Oh,
1,
I
2,
think 'cause I
3,
saw
4.
the
Here got
double
bromine.
bond O here, then I just drew it there without seeing the formula.
Walao. Don't look at this. Look at this. I tell you all naming don't need to stress. But look at the thing this direction you must know. This direction you don't need to know. Okay? Can? Okay. I want you. Actually, do y'all like go and do the organic chem question during the y'all with the organic chem? That's another go and do all the organic chem questions first. Cause if you like you see some you lost you I don't know whether you like ran out of time or what, but I think you might have lost a lot of time. Oh,
Okay. Not all my can. My other questions is better.
your section C is damn long. How long is this paper? 2 hours. Say for step 2 and step 3 and suggest the structure of compound B. Okay, since she didn't attend. Tiagesh, come. You try. From here, let me draw it big. Okay? Elimination of water.
先先有的 industrial
Not industrial, but it's the condition. What's the alternative if you use this? Yeah, so there are conditions. Actually, my time, right, we use this one. Then
That's
subsequently,
industrial.
over the years, they changed to using the corn sulfuric acid. But like I said, you need to be familiar. You need to know this answer. You need to know that this is elimination. Okay? So we started with your mobility. Okay. Then we eliminate, probably get like a double bond. Right? Okay. Then you did something to get compound B. Then after that, it became a carboxylic acid. Did it lose the carbon? 1, 2, 3, 4. 2. So you see that this double bond is this double bond here, right? Correct or not? 1, 2, 3, 4, 5. 1, 2, 3, 4. What does it tell you? Chain lengthening. What do you chain lengthen?
ethanolic,
Ethanol, what?
KCN.
What conditions?
Heat.
Okay, must write. Yeah. Okay. And the name of this reaction is okay. Okay, start. Okay. Now how do I teach this acidic? What do I? Okay, you all have a rough paper. I want you all to write the balance equation for me now. Not asked for fun, I ask because it's often asked. On the track, you don't write anything. You just write the acid.
Is it not one then?
Oh, so turns out nobody knows how to write the hydrolysis equation. Yeah, I remember. Oh, I very sad. I very sad. Because you all memorized not a single one of you all did.
I am extremely upset.
Then how about the O?
Think you tell me. Oh, you need O. So oxygen is does oxygen breathe? That's why, sorry, does acid breathe? That's why got oxygen.
No.
Here or not? She gave you all the she just gave you all the right hint. Tiagesh, do you hear?
Yeah, I know.
What did she say?
It's elephant high chair, my teach. Must two elements. Then O the balance oxygen to H must balance this, and then C, which is
Did
charges.
you say elephant?
Elephant on high chair.
That one is for half equation.
Oh,
This one is not half equation.
same thing.
right. Except in no question. Möchten Sie eine Glas?
Product.
What's the other product? You ask me question, I tell you yes, no. You can ask me, is it this, is it that? I'll just tell you yes, no.
Is it just hydrogen?
Nope.
Is it
NH2.
Nope. And it was very weird.
NH3?
So this one under go acid hydrolysis give primary amine.
Wait, is there HCN?
Nope.
Is
Then where
that,
does
is
CN
it
go?
is it NH3 then? H4 acid,
I think you got it. Yeah. Okay. Okay, Naomi got it. I draw you. Back up. Uvia, you write your formula like that, very hard to see one. You must draw it out. There's a reason why I draw out. The good. It's like a Diablo knockoff.
Yeah. Okay, never mind.
No Diablo. Right?
No.
Oh, I don't know.
No, okay.
And you just walks around whacking stuff.
Go. Like.
It's very game, but it's now. I think they're doing version 4. Supposed to come out this year, but I don't know got a delay for COVID. But yeah, we played the Diablo 3. So
Sorry, like we just go fight.
every time it was like forgot we're supposed to kill a monster. What's it called? The Reaper of Soul. Yeah. But last time it was like two this one is player and it's not Diablo. It's a game that's inspired by Diablo. So you play like the whole interface is like Diablo.
Like PlayStation.
He got PS5 and it's his new wife.
Correct.
Naomi, how you check?
That's right. Wait. There.
You try to do his fault.
Oh, it's not part of it, right?
Why? What?
No.
Oh, wait. Let me. The H2O
Okay, see,
flat.
it's easier, right? When you draw it out, then you can see where they move, right? Okay, I got it already. Since you're at this one, I'll do hydrolysis as well. You all don't know I scared.
Compound.
Same compound, but now you do alkaline hydrolysis. The product is different, Okay, product is different, Product is different. Same pattern, but you're gonna get a different compound if you do alkaline hydrolysis. What is the reagent and condition for alkaline hydrolysis?
Alkaline.
You cannot say alkaline. I must be very specific. Okay, balance your equation. You can use potassium also. Any alkaline. I'm cold. I got water here. I didn't know.
Is that like 3 products now?
No.
There's only 2.
I told you it's a different story.
Very different.
1, 2, 3, 4.
No, your product is different. We do the same product here.
Oh, you mean the I know.
3, 4.
Okay.
Oh, am I correct?
Oh.
Got it.
And this is something very simple, often asked, but not everybody knows. Darling, are you okay? Your equation is not complete. Where did the line go? It's very similar. You have D, but then now you use base of
H3.
Okay, then your O and Okay, balance already. Okay, right. So should have gotten the first part one and part two. Okay, blah blah blah. Okay, step 5. Compound D reacts with iodine via electrophilic addition mechanism. Oh wait, let me draw because Shu doesn't know. Okay, I hope she tries at home. Okay, so you will get this and ammonia. Okay, reason why you get ammonia, remember imagine you have ammonia ion, you have NaOH with you, and you right. Okay, so we will balance the O's with OH minus and H2O. Okay, then total got 3H. Overall negative, one negative on the left side, and one negative charge on the right hand side. Okay, and okay, electrophilation compound D. By considering the cat ion immediate form, explain why this one is the step above or below one, right? Correct or not? And you have 50-50. Looks like. Why they didn't give you? Oh, wow, they quite. The electrophile. Okay. Question. Here, they do electrophilic addition, right? Mechanism, right? Then they ask you to explain why you have a racemic mixture, right? Then you go and use electrophile could have attack. But in two, electrophile is the first step. Second step is electrophile. Correct or not? I think that the other thing that join in, you have your. I just very simple. Okay, let's say you have right? Then you right? Then you have your carbocation ion. Then this is the part that's trigonal planar, right? But the other one coming in is a nucleophile, right? So 50-50 that is nucleophile. That's why you didn't get this mark. Okay. So doesn't mean electrophile means everything is electrophile. No, you have to be very clear what is going on. So that's why you. Okay, then this is trigonal planar. Okay, attack the trigonal planar carbocation ion. And part 4, cyclic ester with the same formula as E can be found in step 5. Just a and easier draw, yeah. Okay, so this is the. Actually, she probably has it anyway. Okay, so this is your electrophilic addition, and you have step. Then this is the nucleophile that's supposed to attack on the top or the below, right? But it can also undergo O minus here itself, right? Can act as a nucleophile to attack this positive charge here. Then you form a cyclic ester. So when you are doing, they didn't ask for the mechanism, right? This is a bit hard. If they ask you for the mechanism, you can see. If you didn't write the mechanism, then you won't be able to see this. Okay? And let's see. I'll read one hydrolysis. It's the secondary undergoing both SN1 and SN2. This one is equal when this is greater. Okay. So just run rush through this. How was the structural elucidation? Oh, you did quite well. Structural elucidation.
That's 6.
5 out of 6.
Mm.
What is 2 conjugated double bond?
I saw it somewhere.
What's the meaning of conjugated double bond? You're right. KLMN. How come you didn't get all the marks? Wow, okay, now let's look at this. Why so many zero? Last one.
Oh, yeah. Right, that's
Step 10. What's the section? You cannot just write substitution. Cannot just write substitution, my dear. You must say what kind of substitution. Is it nucleophilic? Yes, nucleophilic. Explain why the phenol group does not react in step 1. Why the OH doesn't get substituted with CF. This one, the answer already like boom in my head already.
Resonance capacity.
Is it what? Okay, close enough. Because the bond is very strong, right? Broken. Why? Yes, P overlap with the particles of the benzene ring, making this bond strong and possible to be broken. Okay, hence it does not undergo nucleophilic sub.
I wrote that, but I guess it wasn't enough.
I see.
And then the bond is like strong. I wrote that. So like that's no charge. Right. But I because one like if it's a bit off, then they just don't give you.
I think because you were phenol is a weak nucleophile.
Not. Oh.
Yeah, then you talk about its negative charge being this. So it's a bit odd. If your Cl is coming in Cl, I believe your nucleophile is on the Cl. Your nucleophile is the PCl5. You wrote it as though the nucleophile was here. So it was reversed. Okay, reagent for step 2 and 3. Wow. Why? Why? Why didn't you get these?
What did she?
Concentrated?
No.
They also very strict. Some schools would have accepted without the concentrated. Okay, I step 2 and 3. One reagent.
In a sealed tube. And then step 3 is K2 CR2O7 and dilute to 0.4.
I use K.
Wait, I forgot everything.
Wait, I worksheet that I made wrong since it didn't reach you guys.
Can phenol be oxidized? No, right? No, right? So yeah, can use, right? Class pass.
I think 10 people. Only one.
Yeah, classes were only oh,
How can they get A? Like, this is not even in the book.
they have no friends when they study. God, online volleyball, they all have to go to camp and like go. I'm not going. I got an A. I'm like, okay. She takes like 2 H3s, so
2 histories.
yeah.
How
Amazing.
if
I don't know. Very
Yes. The next part. We did already. Okay, then part 4. Step 4, compound Q. In step 4, you have a compound Q, which is one. First reacted a reaction. Upon heating, compound S was obtained and thus contain acidic groups. What's the identity of the structure of S? Okay, so there's finished number of carbon, right? Cl, this Cl was gone, right? We lost Cl and 1, 2, 3, 4, 5, 6, 7, 9. Lost 9. So what's a hydrogen and chlorine? So what happened? What do you need this to happen? I know. Why?
It's thing, right?
Condensation.
You get HCl. Yeah, but you can only get HCl what?
It's not isn't it? You HCl. No.
Oh. From double one. Okay.
Why not? You're moving a Cl, right? So it should.
I don't know, but for a moment I thought the H came from the phenol group, like the OH group. It's like,
Eliminate, right? Will look by heating. You do elimination of HCl, I use KOH ethanol, followed by heating. They use sodium, then this become the phenol part will become a nucleophile. Then it will attack to remove HCl, but I think hard for this one. And the C is lost, slightly proton is on the Q acid base, the phenol side. Oh, okay. So the reason why I cannot do elimination is because they tell you that it doesn't contain any acidic group. If I did elimination, right, the phenol group will still be present. Then the acidic group. Okay, so we have sodium so that it turns into O minus, make a phenoxide ion, start as a nucleophile. Okay, then as a nucleophile, it will sub that Cl. So via nucleosub, then you will get this structure. The ether structure. Okay, then they say that compound T is a constitutional isomer of Q, this one. Then they get B. So how do you distinguish from Q? This one is easy. How do? Okay. Did they take away your marks or they did because you didn't write state symbols? Oh, that's so sorry, my dear. Okay, so this is it. It's not as hard as y'all say, but it's not easy. It's quite long. I look through it, I also feel like but chem papers always feel very long. Let me bring for y'all the solubility equilibrium. Which of y'all take note of this? And I have news for y'all for the next 4 weeks.
No,
You have lots of homework.
No, but lesson will be online the next 4 weeks.
Oh, why?
I'm going France for 1 month.
Huh?
Why?
Buy your conference.
Want me to bring to?
I can pass it actually.
It's so popular. Everybody want to pass her worksheet.
No, because we're on the same level. My class is directly opposite hers.
Because I have a day break with her. Like, say,
Normally I
So this whole package is for when I'm away. So don't worry, it's not for today. So is that less stressful?
oh, also, I'm going India in
You have it online. Then you're online for a very long time.
Oh yeah, for like
7 weeks.
I'm going there for 3 weeks. You kind of like start now. You guys go and then like come back to exams.
yeah. No, but he's studying there.
You say that now, but
No,
once you're there,
seriously. No, I can't be like partying for like 3 weeks, right?
but you're around like family and friends.
My
then,
mom
like,
said she'll lock me up in a room.
Wow.
Let's see.
Have you all finished nitrogen compound already?
No, we haven't started.
One
I finished
We
already.
just started carb. Oh wait, we finished carb split this week.
My teacher finished already. She goes so
Can we share one? So nobody has started on solubility equilibrium in school lah. So we are well ahead, right? Covers for my buffer. Okay, let's attempt the first question.
Okay, so from next week onwards.
Yeah. So you want anytime also can. I will wake up anytime in France for
what's
you.
the time difference?
6 hours.
Oh no, no.
Like do lesson at 6 is noon there lah.
At 6.
Let's say if you all do 6 p.m. lesson, then it will be noon in Paris.
No, wouldn't it be like
6
oh,
p.m.
behind? Oh, I thought it's in front. So I like what night. Did you got me a timetable?
No, I don't think we get time to
Oh my god.
Hey, giving time. Say next week.
So teacher time. Is it like a committee doing it?
No, I think he said that there's a new timetable coming up. So I don't know how the next week lesson we are going to do. So I cannot tell you what we're going to do next week. Then I said, okay. Then next week he come in and he just say we are going to do this.
So what?
Do you have correction group?
Left it at school.
Left it.
What?
Oh my god, on Thursday I was studying. Thursday I had 3 hours of camp.
Yeah, 3 hours.
Yeah, and then I study until I leave like half my station in school.
How do you until you leave?
At home, you always leave your pencil box behind.
Yeah, is it? Huh?
You always leave your pencil box behind.
How pencil box?
You always leave your stationery behind. One.
Yeah, like you know, study and then
Like
Wow.
giving souvenirs to people.
yeah, that's what my friends say. Like they're leaving so
That time also he left his entire pencil box here. Then we got a Grab driver to deliver to
oh
him.
yeah.
Whoa. I didn't bring my calculator. I forgot.
Calculate. I give it back in my package. One is only cover slip, then you cover now. Got two, right? Dudes. Okay, you gave two. Good. Yeah, where's
I don't have the cover page. Wait.
I think you didn't give me the. Oh, I see. Your cover now. I see. Yeah, it's fine. Okay. It's here. Wait, better label.
Stay.
Just give me a staple for now. Do I have 25 tissue?
Page 1.
Page 21. 25. To 31.
Okay, what page is it?
173.
Thank you.
You all know that from alcohols all the way to carboxylic acid is the most commonly tested against. This analysis past 10 years, the mark weightage is the highest for these chapters.
Which chapter?
Alcohols through to carboxylic acid. There's two sets. I went to the one.
Concentration. Okay. For the ions.
I guess they're putting on the fridge because they're going to fry. Only like let's see whether they still have the outline things. They do. I think us. What do you get? What do you get
So which one?
for part B?
1.3 times 10 to the power of 7.
7. Wait. Maybe I'm just reading this calculator wrongly because I got negative 14, which 6, 9 times 10 to the power. Negative 14. Yeah, 1.3 times. Am I keying it in wrongly? I don't know what's happening.
Your square is outside. I mean, it's not inside. Wait,
It is inside.
are you sure?
That's how. You check.
Wait. Times 10 to
Show me on your calculator. I don't know why. No, that must mean. So maybe it's like me.
Wait, what's happening? Taxi.
Oh, you have to put brackets.
Oh.
If not, like when you put times, I think it changes.
Plus you should, try to scan it, like the background spotting. Can
Is
you
this
two
the
sets
same
of
thing?
answer?
Wait, is this for true?
This is the answer.
Oh,
I give it two home.
oh my god.
Both you take. doing the test question. Okay.
What's the answer for the second?
A or B?
C. Maybe I should recover.
Yeah. I shall do something. Oh, I think there's 7. Did I bring 7?
The other side.
Oh, okay. Answer is 99.7%.
99.7%.
Yep. Oh, one question.
40C.
Hold on. 1.69 times 10 to the power minus 12.
Okay.
10 to the power minus 12.
1.69 times 10 to the power 12. So question for me, the under right below some point I don't need to. Okay, so you all know how to write your KSP expression, right? It is B plus and then CR O4 2 minus. Okay, this is the expression. The B answer is 1.30 times 10 to the power of minus 7 mole per dm cube. Okay, but C answer is 1.69 times 10 to the power minus 12. Do you get it?
I don't understand what's happening in part C.
Okay, let me look at it. Okay, so you like chromate and then you add nitrate. Potassium chromate. On what concentration does the first trait of precipitate? Okay, this one is what this is what happens when you add or cause precipitation to occur. Okay, so you have this. Okay, you have a potassium chromate solution. Okay, K2CrO4. Okay, then you're going to add lead nitrate, which is a soluble, and 3, 2. Okay, so what happens is when your lead ions and your chromate ions meet, they will form the PPT. Okay, what happens when precipitation occurs? Precipitation occurs. What happens at this point?
The product of those two things is greater than KS.
Okay, so the next part is more than KS. Okay, so at this point, right, what we do is we assume that your KSP, right, okay, is equals to the concentration of lead times the concentration of chlorine. Okay. Do we have the KSP? We have, right? We found it in the previous part, right? Is it this one? Or did it give you?
The one
0.6, right? Even, right? Okay, this is 0.69 minus 14. Okay, then your concentration, is it question? This is what we find. These are atomic concentration given to you?
0.01.
0.01, correct. Then you the
Like it's like saturated solution.
when once this is right, what left behind will be this. Whenever you have precipitation occurs, right, if excess from the precipitation, what you have left behind, right, the saturated solution will follow this whereby your KSP equals to the ionic. Once the set, then you will find your answer in part C. So just to make this a subject. Okay. Now do 37 instead. Do the revision. Sorry, 30. Sorry, 36. I wanted to scan this one. Don't have. For sure. Okay, question 36. Okay, they give KSP, right, which is 0.3 times 10 to the power of minus 10. Okay, then you need to find the concentration of barium in the saturated solution. In this case, squared, correct? Oh yeah, what's the definition? Mole square? dm minus 6, right? Okay. Then this one 1.3 is about 10. Then you have century being that. What's your when you square root?
1.14 times 10 to the power of negative 5.
Thank you. Okay. Then part C suggests barium carbonate is very poisonous if ingested, although KSP is not significantly lower than that of barium sulfate.
Is it because it's soluble?
Carbonate is not soluble. All carbonate is insoluble.
I don't know that.
Because carbonate can react with acid. What was the in the yellow book? I remember through doing
It's the same.
exact same question.
I don't remember.
It's the same person.
Online lesson, nothing goes in.
Was it online?
It was last week.
Oh, soluble.
Didn't. There last week.
The potatoes. Oh my god.
That's the 6 p.m.
Bye.
Oh yeah. Maybe it's because it was at 6 p.m.
Okay, because it reacts, okay? Barium carbonate reacts with HCl in the stomach to barium chloride, which is soluble. Okay?
There's HCl in the stomach.
Yes, the acid in your stomach is HCl. Did you know that?
I didn't know, that's why I cannot do it.
Yeah, so you can read HCl. You can be a cute. And also the acid man. Because Marvel needs another hero. And then just
You know, I actually haven't watched it. Yeah.
it's
Because
been like
the thing is like
it's almost 3 years
I
already.
already know everything that happens. So I'm like, what's the point?
But,
Like a 3-hour
but the
movie.
effect is really watching. The effect is very good.
I forgot everything.
To watch is very worth watching.
I kind of want to rewatch everything because I can't even remember action movies. Maybe I haven't watched any of them.
Rubia doesn't watch TV.
No, I do.
She watched.
I know,
Just
like,
watch
movies.
different.
Even Sana's planning to watch it. Actually, she's not. Her family's planning to watch it.
She doesn't watch any.
she writes so many notes, then she don't remember.
I read. I remember later. What are we supposed to do now? We're supposed to be doing another thing. I thought
Just continue doing it.
Oh my gosh. I was just.
For sure. I hope the scan came out better this time. She doesn't look so horrible on my phone.
I don't know how to use your calculator to solve simultaneous equations. Is it not? S squared.
37.
Looks cleaner.
Yeah.
B.
Yeah.
X squared.
S. I mean, yeah.
You want simultaneous or
why is that-
quadratic?
Oh, sorry. I got confused. Sorry. Dude. Oh no, one.
No. put your x square coefficient, and constant.
It's x cubed, right?
You just need cube root.
That's why.
Oh, I just realized. Sorry, I was not.
Oh, then Naomi's head is not here today.
It's too early in the morning.
Is it? You strike me as an early bird though.
No, I normally
Mm.
like because of like training and everything. I haven't
You
been
strike
able
me
to
as
sleep.
like somebody who wake up at 6 a.m. maybe.
No, I hate every
No
single
lah.
every single morning when I go to school. I'm the type of person to put the jacket on the head and then like
Yeah.
just like sleep there until like the teacher comes in and like I'm like
That sounds like.
I'm not an early person.
But also yeah, I cannot function in the day morning.
I hate
Teach okay but sometimes when I want to sit down and concentrate on something on the computer, I have to do into the night one. But the PM shift.
PM shift.
It means my brain functions in the night. My peak performance hour is like 12 midnight to 5 a.m. But then I just
Yeah.
so I'm at my peak. Then my husband on the other hand automatically 6:45, don't need alarms can wake up. Yeah. Okay, so this one the KSP a bit more complicated, right? Because there's a square, right? You have a magnesium 2 plus and then hydroxide squared. So the units is
Mole cube. DM -9.
good. Okay.
Oh wait, when they ask for KSP expression, we need the unit.
Yes. They wrote about stating its unit. Chala, you always blind. Selective vision. There's selective hearing and your selective vision. Okay.
Answer for C.
So your KSP, we are supposed to find the. They gave you, is it KSP?
Yeah.
Yeah.
Okay, so this is 2.00 times 10 to the power minus 11, right? So I have one more of this magnesium hydroxide. Remember last week I went through this question? Okay, if I have X moles of these being dissolved, then I'll get X of this and X of this. So this is 2x times 2x squared bracket square. Right? So you have to, so your x is equals to this divided by 4 cube root. Right? I just SB by 4 root. Okay? Then your answer is 1.71 times 10 to the power minus 4. What's the unit?
Mole per DM cube.
Then you all know how to concentration of hydroxide, just times 2. Okay? Yeah. Okay, part C, answer.
Is it just 1.71 times 10 to the power of -4 over 0.54 times 100?
Then you take 100 minus, because you want extracted, right?
Eh?
Did they ask for percentage extracted?
Yeah.
Yeah, then you take 100 minus.
Isn't this the
Whatever you told me is the amount left. The step me was the amount left. They want the amount extracted. So just 100 minus left equals extracted. Got it?
Ui.
What was the formula you gave me just now?
1.71 times 10 to the power of -4 over 0.054 times 100.
0.054. 100. Right? So 0.03%, right?
Yeah.
What is this? This 1 point, this is amount that's left behind, ma. The magnesium in the solution. That's the one left behind. This is the original amount. This is the left behind. That means minus is what was extracted. Okay? Okay? Okay, send here. Your homework. 38, 39, 40. Just finish the 2 pages. The answer is actually mailed to your. Yeah, the whole thing is clear. Day tomorrow. Early day, like Monday. Or was it Saturday? Did I mail on Saturday? Yeah, I mailed it on Saturday.
The close on Sunday, what?
I mailed last Saturday. It takes so long. Usually it's like 3 working days. Somehow you all receive very fast, right? Is it fun to receive mail?
Yeah.
I like receiving mail too. Except for when bills. Receiving bills is so fun. Before technology, we used to write to people, write to each other.
Yeah.
And then and it's a very girl school thing. You'll write to your classmates or mates. Then like in the morning when you in school, you leave the letter on your table.
Oh, we still do that.
Oh, you still do that?
Yeah, in RGS.
Oh, she's left out. Nobody write to her.
Who writes letters?
I do.
Like you just write nonsense. You just like oh, just really nonsense. You do maybe this lesson boring. Somehow you bitch about other people. Then somehow like wow, you walk to the table, wow, I got so many letters, very happy. It was such a thing, you know, that like having like the more letters you have, the more you have, the better.